All right, welcome back. So let's do a sound check here. So output through headphones, input through the headphones, levels look good. So this is going to be part three of the MCP course. These courses are designed to have basically two objectives. The first objective is to just be brought up to speed on the subject in a kind of high level, in a kind of seeing a broad 100 foot view. And then the second objective is to go in depth and actually get the skills that an engineer or somebody working um, in the weeds with the technology would get. So um, it should let's briefly go over. I'm pretty sure it says that. Where did it say that? Um, okay, so I'm pretty sure it says that somewhere. I'm not just making that up. I want to see where. Well, anyways, maybe I'm just making that up. Well, no, here we go. Here we go. So yeah, Unit 1 is that first goal, and you can see you get a certificate at the end of Unit 1. So you don't have to do the whole course to get a certificate. You can just take Unit 1, and now you've got a certificate that claims that you have kind of a high level, forest for the trees sort of view on this subject, and then you can go further in and get another certification that says that you actually have uh, the actual like engineering skills. So my goal is to at the very least get through this unit one to get that certificate because that when it says like so for this course prerequisites for the course are a basic understanding of AI and LLM concepts. If you have that Unit 1 certificate from, for example, the LLM course, you could definitely check this box off. So if I ever take another course that asks for a basic understanding of MCP concepts, and I have this Unit 1 certificate, as I do for the agents course, I can check that box off, and you get a special badge for it as well. So if I go to my here and then yeah, so here's my organizations. I should have a like an actual uh something in my profile should indicate that I've completed uh unit one of unit one of the MCP course. Not the MCP course, the agents course. Uh, okay, well, maybe not. I just don't want to make a lot of stuff up. I want to like verify what I'm saying here, which I don't know if I can. Oh, here we go. Suffix certificate title. What does that mean? Uh, oh, certificate. Does this mean I got the? Oh yeah, here we go. So I do have the certificate. Perfect. Yeah. So this is what you get after Unit 1, and you can you can wait. I'm so confused. This is for the MCP course. Why is this sent to me? Now I didn't. Oh, and this is somebody else's name. Why did I get a note? Oh, maybe because I'm following that person. That's probably why, yeah. Because I'm following that person. Yeah, so these are probably the people that I'm following. It looks like a bunch of them got, so I get alerted when they get the certificate. So that's the kind of certificate I'll get after I complete the MCP course. But I should have gotten that for the agents course. Uh, well, anyway, no further ado. This is the introduction to Model Context Protocol Unit 1. Welcome to Unit 1 of the MCP course. In this unit, we'll explore the fundamentals of Model Context Protocol. What you will learn in this unit, you will understand what Model Context Protocol is and why it's important, learn the key concepts and terminology associated with MCP, explore the integration challenges that MCP solves, walk through the key benefits and goals of MCP, see a simple example of MCP integration in action. By the end of this unit, you'll have a solid understanding of the foundational concepts of MCP and be ready to dive deeper into its architecture and implementation in the next unit. Importance of MCP. The AI ecosystem is evolving rapidly with large language models, LLMs, and other AI systems becoming increasingly capable. However, these models are often limited by their training data and lack access to real-time information or specialized tools. This limitation hinders the potential of AI systems to truly relevant, accurate, and helpful responses in many scenarios. This is where MCP, Model Context Protocol, comes in. MCP enables AI agents to connect with external data sources, tools, and environments, allowing for the seamless transfer of information and capabilities between AI systems and the broader digital world. This interoperability is crucial for the growth and adoption of truly useful AI applications. Overview of Unit 1. Here's a brief overview of what we'll cover in this unit. What is Model Context Protocol? We'll start by defining what MCP is and discussing its role in the AI ecosystem. Key concepts. We'll explore the fundamental concepts and terminology associated with MCP. Integration challenges. We'll examine the problems that MCP aims to solve, particularly the M times N integration problem. Benefits and goals. We'll discuss the key benefits and goals of MCP, including standardization, enhanced AI capabilities, and interoperability. Simple example. Finally, we'll walk through a simple example of MCP integration to see how it works in practice. Let's dive in and explore the exciting world of model context protocol. So I have some sort of preconceived notion of like what I think this is, and it could be very, very wrong. So I'm going to be ready to completely throw that out the window. So to do that, let me first start by saying what I think MCP is without reading any further, and we'll see if I'm more or less correct or if I have to throw that understanding out the window. So my understanding of MCP was that it was basically an alternative to something like YAML or JSON, and it allows you to have machine-to-machine communication between your LLM and between some sort of remote reg server. So you can tie the two together in some way that allows you to in a standardized way go out to other reg servers to enhance the capabilities of your LLM. So we'll see if that's what it is. If it is, then I'll hold on to that understanding. If not, then I'll make sure to throw that away. All right, so key concepts and terminology. Before diving deeper into model context protocol, it's important to understand the key concepts and terminology that form the foundation of MCP. Um, This section will introduce the fundamental ideas that underpin the protocol and provide a common vocabulary for discussing MCP implementations throughout the course. MCP is often described as the USB-C for AI applications. Just as USB-C provides a standardized physical and logical interface for connecting various peripherals to computing devices, MCP offers a consistent protocol for linking AI models to external capabilities. This standardization benefits the entire ecosystem. Users enjoy a simpler and more consistent experiences across AI applications. AI application developers gain easy integration with a growing ecosystem of tools and data sources. Tool and data providers need only create a single implementation that works with multiple AI applications. The broader ecosystem benefits from increased interoperability, innovation, and reduced fragmentation. The integration problem. The M times N integration problem refers to the challenge of connecting M different AI applications to N different external tools or data sources without a standardized approach. Without MCP, M times N problem. Without a protocol like MCP, developers would need to create M times N custom integrations, one for each possible pairing of an AI application with an external capability. So your model, to go out to a database, a file system, or a calculator would need a unique API. Each application would need to integrate with each tool slash data source individually. This is a very complex and expensive process, which introduces a lot of friction for developers and high maintenance costs. Once we have multiple models and multiple tools, the number of integrations becomes too large to manage, each with its own unique interface. So model one, two, and three, database file. Yeah, so you have to have one for each. With MCP, M plus N solution, MCP transforms this into an M plus N problem by providing a standard interface. Each AI application implements the client side of MCP once, and each tool slash data source implements the server side once. This dramatically reduces integration complexity and maintenance burden. Each AI application implements the client side of MCP once, and each tool slash data source implements the server side once. Core MCP terminology. Now that we understand the problem that MCP solves, let's dive into the core terminology and concepts that make up the MCP protocol. Okay, so I think I was kind of on the right track, but I think I was a bit far off. I think thinking of it as like an alternative to JSON or YAML um, really doesn't do it justice because JSON and YAML you would configure a lot of parameters and it's kind of a whole job in and of itself to get the JSON and YAML the way you want it if you're building out an application. This is more lower level, just a standardization like USB-C. So MCP is a standard like HTTP or USB-C and is a protocol for connecting AI applications to external tools and data sources. Therefore, using standard terminology is crucial to to making the MCP work effectively. When documenting our applications and communicating with the community, we should use the following terminology. So yeah, it's going to be quite a bit like HTTP is different than JSON. You don't generally, I mean, you make a API call using like an HTTP GET or PUT or something like that. But um, yeah, you don't usually modify the HTTP itself. Sometimes you would modify, yeah, and oftentimes you would modify a JSON or YAML file. You wouldn't modify an HTTP file. You would, yeah. So I think that's not really the best way to think about MCP. All right, so components, just like client-server relationships in HTTP, MCP has a client and a server. Host, the user-facing AI application that end users interact with directly. Examples include Anthropic's Claude Desktop, AI-enhanced IDEs like Cursor, inference libraries like Hugging Face Python SDK, or custom applications built in libraries like LangChain or small agents. Hosts initiate connections to MCP servers and orchestrate the overall flow between user requests, LLM processing, and external tools. Client, a component within the host application that manages communication with a specific MCP server. Each client maintains a one-by-one connection with a single server, handling the protocol level details of MCP communication and acting as an intermediary between the host logic and external server, an external program or service that exposes capabilities, tools, resources, prompts via the MCP protocol. A lot of content uses client and host interchangeably. Technically speaking, the host is the user-facing application, and the client is the component within the host application that manages communication with a specific MCP server. Capabilities. Of course, your application's value is the sum of the capabilities it offers. So the capabilities are the most important part of your application. MCPs can connect with any software service, but there are some common capabilities that are used for many AI applications. So we've got a table here with three columns and multiple rows. Columns are capacity, description, and examples. So the first capability that is used for many applications is tools. These are executable functions that the AI model can invoke to perform actions or retrieve computed data, typically relating to the use case of the application. For example, a tool for a weather application might be a function that returns the weather in a specific location. The next AI capability are resources, read-only data sources that provide context without significant computation. For example, a researcher assistant might have a resource for scientific papers. Next is prompts, predefined templates or workflows that guide interactions between users, AI models, and the available capabilities. For example, a summarization prompt. Next is sampling, server-initiated requests for the client/host to perform LLM interactions, enabling recursive actions where the LLM can review generated content and make further decisions. For example, a writing application reviewing its own output and decides to refine it further. In the following diagram, we can see the collective capabilities applied to a use case for a code agent. This application might use their MCP entities in the following way. Okay, so the diagram has the LLM, and now we can see instead of the LLM having to have three connections, one for each of these, it can have one connection to MCP, and then similarly the code interpreter, software documentation, and code style prompt resources. Well, they're not all resources. One is a tool, one is a resource, and one is a prompt. But regardless of them all being different things, which you could imagine would be complicated because, think of a USB connection, right? It's like back before we had USB, you had all these different kinds of ports that you just kind of had to get lucky that uh, your device used, like PC port, PCIe, different kinds of ports. Um, so having a universal, even though USB is like as ununiversal as could possibly be. There's USB A, USB C, USB B. Like there's mini, macro. Like there's data cables and non-data cables. So, but even so, like without that, the standardization is facilitates a lot, even if it's oftentimes not perfect. This application might use their MCP entities in the following way. So for a tool named Code Interpreter, um, it's a tool that can execute code that the LLM writes. That's one way it might use it. The next one is a resource named documentation. So a resource that contains the documentation of the application. Next is prompt named code style, a prompt that guides the LLM to generate code. Next is sampling named code review, a sampling that allows the LLM to review the code and make further decisions. Conclusion: understanding these key concepts and terminology provides the foundation for working with MCP effectively. In the following sections, we'll build on this foundation to explore the architectural components, communication protocol, and capabilities that make up the model context protocol. All right, so next is architectural components of MCP. In the previous section, we discussed the key concepts and terminology of MCP. Now let's dive deeper into the architectural components that make up the MCP ecosystem. Host, client, and server. The Model Context Protocol, MCP, is built on a client-server architecture that enables structured communication between AI models and external systems. So host, client, server, and then the tool. So the MCP architecture consists of three primary components, each with well-defined roles and responsibilities: host, client, and server. We touched on these in the previous section, but let's dive deeper into each component and their responsibilities. Host. A host is the user-facing AI application that end users interact with directly. Examples include AI chat apps like OpenAI ChatGPT or Anthropic's Claude Desktop, AI enhanced IDEs like Cursor, or integrations to tools like Continue.dev, which I've never heard of before. Let's take a look at that quick. So this is a amplified developers. Okay, yes, so this is another vibe coding tool, which is good. Vibe coding tools are good. All right, and then the final example of a host, which is a user-facing AI application that end users interact with directly, is custom AI agents and applications built in libraries like LangChain or small agents. Hosts' responsibilities include managing user interactions and permissions, initiating connections to MCP servers via MCP clients, orchestrating the overall flow between user requests, LLM processing, and external tools, rendering results back to users in a coherent format. In most cases, users will select their host application based on their needs and preferences. For example, a developer may choose Cursor for its powerful code editing capabilities, while domain experts may use custom applications built in small agents. Yeah, Cursor's an interesting one. I'm used to using VS Code, but I've been very curious about switching to Cursor. I know a lot of people use Cursor. I thought I had it set up, but it looks like I don't. All right, so the next one is the client. So it has a host, a client, and a server. We learned about the host. So next, let's learn about the client. The client is a component within the host application that manages communication with a specific MCP server. Key characteristics include each client maintains a one-by-one connection with a single server, handles the protocol level details of MCP communication, acts as the intermediary between the host logic and external server. Server. The server is an external uh, program or service that exposes capabilities to AI models via the MCP protocols. Servers provide access to specific external tools, data sources, or resources, act as lightweight wrappers around existing functionality, can run locally on the same machine as the host or remotely over a network, expose their capabilities in a standardized format that clients can discover and use. Okay, and we got cursor now. So communication flow. Let's examine how these components interact in a typical MCP workflow. In the next section, we'll dive deeper into the communication protocol that enables these components with practical examples. So here's the how they interact in a typical workflow. So the first thing that typically happens is user interaction. The user interacts with the host application expressing an intent or query. Next is host processing. The host processes the user's input, potentially using an LLM to understand the request and determine which external capabilities might be needed. Next is client connection. The host connects its client component to connect to the appropriate servers. Next is capability discovery. The client queries the server to discover what capabilities, tools, resources, prompts it offers. Next is capability invocation. Based on the user's needs or the LLM's determination, the host instructs the client to invoke specific capabilities from the server. Next is server execution. The server executes the requested functionality and returns results to the client. Next is result integration. The client relays these results back to the host, which incorporates them into the context for the LLM or presents them directly to the user. A key advantage of this architecture is its modularity. A single host can connect to multiple servers simultaneously via different clients. New servers can be added to the ecosystem without requiring changes to existing hosts. Capabilities can be easily composed across different servers. As we discussed in the previous section, this modularity transforms the traditional M times N integration problem, M AI applications connecting to N tools/services, into a more manageable M plus N problem, where each host and server needs to implement the MCP standard only once. The architecture might appear simple, but its power lies in the standardization of the communication protocol and the clear separation of responsibilities between components. This design allows for a cohesive ecosystem where AI models can seamlessly connect with an ever-growing array of external tools and data sources. Conclusion. These interaction patterns are guided by several key principles that shape the design and evolution of MCP. The protocol emphasizes standardization by providing a universal protocol for AI connectivity while maintaining simplicity by keeping the core protocol straightforward, yet enabling advanced features. Safety is prioritized by requiring explicit user approval for sensitive operations, and discoverability enables dynamic discovery of capabilities. The protocol is built with extensibility in mind, supporting evolution through versioning and capacity negotiation, and ensures interoperability across different implementations and environments. In the next section, we'll explore the communication protocol that enables these components to work together effectively. All right, so now we're going to take a quiz. This is just a public quiz, so I feel fine doing it on a YouTube, public YouTube video. It's not a private thing behind a paywall or anything like that. Um, so here's cursor. I've been meaning to do cursor. Let's open my metronome project in cursor. So it looks like I have to log in to something to cursor in order to use it. Okay, so now I'm logged into Cursor, and it looks like I get to use Claude Sonnet 4 and Claude 3.5 Sonnet for free. So I've got various options. So yeah, this might be interesting to let's so debug this. So identify bugs in this file and fix them. All right. Okay, so here's the quiz. MCP fundamentals. So what is the primary purpose? It's to enable yep. So there we go. Correct. Facilitate interoperability. What problem does MCP aim to solve? The M times N integration problem, where you need a new kind of integration for each thing you integrate with, which increases the complexity of your integration by so much. You just need a standardized way of integrating with anything you integrate with. Correct. So it standardizes connections to avoid uh, having the need for so many custom integrations. Which of the following is a key benefit of MCP? Yep, standardized. There we go. Just as before, standardization and interoperability. In MCP terminology, what is a host? So host is um, I'm going to go with this one, user-facing AI application. If I'm wrong, I'm wrong. Yep, that's right. Okay, so the host is the application users interact with. Okay, so what does the M times N integration problem refer to in the context of AI applications? Uh, so, right, so the complexity of developing M features for N different. I think I'm going to go with B. This one kind of sounds like it could be the right, but I think it's this developing features thing is not. Yeah, and user segment set, that's nonsense. So I think B is the right answer. There we go. So a standardized way to solve it. Yep. And there we go. I got them all right. So the next would be the communication protocol. About halfway in. I got meeting at 1, so I can get to quiz 2. You know what? I think I'm gonna end it here though. So thanks for watching. See you in the next one.